Hello, my dear children. How are you? Now come to the functions. Okay, my dear children. Question number 1. If f of x is equal to x by root of 1 minus x square, comma g of x is equal to x by root of 1 minus 2x square, then g circle f of x is. Here f of x and g of x are given. We have to find the composite function of g and f. Here options. First option is x. Second option b x by root of 1 plus 2x square. Third option is x by root of 1 minus 3x square, and fourth option is 1. Okay, my children. Now, out of these four options, third option is correct. Let us see the details explanation. We have to find g circle f of x. What is the definition of g circle f of x? G of f of x. Okay, my children, that is equal to g of, what is f of x here? X by root of 1 minus x square. So we wrote f of x in these brackets. Again, consider the entire part in your mind, and the entire part is x. So it is in the form of g of x. What is meant by g of x? X by root of 1 minus 2x square. So in the place of this x in this formula, substitute this entire part as x. So we substituted in this function. So x by root of 1 minus x square whole divided by square root of 1 minus 2 of x by root of 1 minus x square whole square. Understood this step, my children? Right. That is equal to numerator. We are writing this part as it is. Now come to the denominator. Under the square root, there are two fractions. Okay. And first we simplify this fraction. X by root of 1 minus x square whole square. So we can get here 2 into x square by 1 minus x square. Square root and square cancel. We get here 1 minus x square as denominator. Okay, understood this step, my dear children? Right. That is equal to, we write this part, numerator part as it is, by, in the denominator, square root of, these two are fractions. Take LCM. LCM is 1 minus x square. Then we get in the numerator 1 minus x square minus 2x square. Understood this part, my dear children? Right. That is equal to, we write this numerator part as it is, divided by simplifying the numerator part in the denominator here, we get 1 minus x 3x square by root of 1 minus x square. Understood this step, my dear children? Right. That is equal to, by simplifying the numerator and denominator, we get x by square root of 1 minus 3x square. Understood, my dear children? Is it clear? Right. Now come to the question number 2. If f of x is a polynomial in x value is greater than 0, satisfying the equation f of x plus f of 1 by x is equal to f of x into 1 by f of 1 by x. Then f of x is equal to, let find the function f of x, which is a polynomial function in x. Okay, my children, that polynomial function is satisfying this condition f of x plus f of 1 by x is equal to f of x into f of 1 by x. Now come to the options. First option x power n, second option is x power n plus 1, and third option x power n minus 1, and fourth option is 1. Actually this is a standard result. We take this question as a standard result. Let us see the explanation. Here option is second, that is x power n plus 1. See what is the given condition, f of x plus f of 1 by x is equal to f of x into f of 1 by x. We wrote that given condition. From this equation we are finding f of x value. So f of x into f of 1 by x minus f of x is equal to f of 1 by x. Understood this equation, my dear children? Right. Now by taking the common factor f of x, we get f of x into f of 1 by x minus 1 is equal to f of 1 by x. Understood this equation, my dear children? Right. This implies f of x is equal to f of 1 by x whole divided by f of 1 by x minus 1. Here we found f of x value in terms of f of 1 by x. Okay, my dear children? Right. Similarly, we find f of 1 by x value in terms of f of x. We get here f of 1 by x is equal to f of x by f of x minus 1. We found f of x value in terms of f of 1 by x. Similarly, we found f of 1 by x value in terms of f of x. Okay, my children. Now, f of x into f of 1 by x is equal to f of x, f of 1 by x by f of 1 by x minus 1. We found f of x value in terms of f of 1 by x into f of 1 by x. We are substituting f of x and f of 1 by x. Okay, my children, f of x by f of x minus 1. By simplifying this equation, we get here f of 1 by x minus 1 into f of x minus 1 is equal to 1. This implies f of x minus 1 is equal to plus or minus x power n. Okay, my children, this is a standard result. No need to prove this statement. Okay, my children, this implies f of x is equal to plus or minus x power n plus 1. If you take any polynomial, okay, my children, which is in the form of x power n plus or minus x power n plus 1, it satisfies the given condition. Understood, my children? Right. Now come to the question number 3. F of x is equal to 4x minus 1 if x is greater than 4. F of x is equal to x square minus 2 if x is minus 2 less than or equal to x less than or equal to 3. F of x is equal to 3x plus 4 if x is less than minus 2. Then f of 5 plus f of 2 plus f of minus 3. We have to find the sum of these three terms. Okay, my dear children. So we have to find this f of 5 value separately, f of 2 value separately, and f of minus 3 value separately. We find these values separately and we add them to find the value of this statement. Okay, my dear children. Now see the options. First option is 15, second option is 11, third option is 16, and fourth option is 19. If you observe here, f of x is defined in different intervals. So here f of x is said to be a piecewise defined function. A piecewise defined function because in different intervals f is defined in a different way. Okay, that is why here f of x is said to be a piecewise defined function. Now come to the solution. Here third option is correct, that is 16. Okay, my children, right. Now see here, I have drawn the number line. On this number line, I wrote the numbers also. I marked the numbers also 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, and so on. If x is less than minus 2, f of x is 3x plus 4. If x value is lying between minus 2 and 3, then f of x is equal to x square minus 2. If x value is greater than or equal to 4, then f of x value is 4x minus 3. So, to understand the function clearly, I have drawn this number line. Now come to f of 5. Where is the 5 value here? More than 4. So, we have to take this function only. So, in that function, we substitute x value. So, 4 into 5 minus 1 because 5 is greater than 4. Understood, my children? Right. That is equal to, by simplifying these two terms, we get here 19. So, f of 5 value is 19. Understood, my children? Right. Now, we have to find f of 2. What is the value of 2? Which lies in which interval this number lies? It lies between minus 2 and 3. So, we have to take f of x is equal to x square minus 2 only, not this function or not this function. So, in that function, we substitute x is equal to 2. So, 2 square minus 2. We get here, by simplifying the numbers, we get 2. So, f of 2 value is 2. Understood the value of f of 2, my dear children? Right. Now, come to f of minus 3 value. In which interval minus 3 lies? In this interval, less than minus 2. If x is less than minus 2, f of x is equal to 3x plus 4. So, we have to take this function only, not this function or not this function. So, in this function, we substitute x is equal to minus 3. So, 3 into minus 3 plus 4. By simplifying these two terms, we get to finally minus 5. Understood the value of minus 3, my dear children? Right. We have found the values of f of 5, f of 2 and f of minus 3 separately. Now we substitute these three values in this expression f of 5 plus f of 2 plus f of minus 3 is equal to By substituting the values and simplifying them, we get here 16. Note, here the function f is said to be a piecewise defined function. I told you already, my dear children, because the function f is defined in different intervals. Remember this point, my dear children. Right. Now come to the question number 4. If f of x is equal to alpha x plus beta and f is equal to set of all ordered pairs, ordered pair 1 comma 1 comma ordered pair 2 comma 3 comma ordered pair 3 comma 5 comma ordered pair 4 comma 7. F is defined in terms of ordered pairs. The function f is defined here in terms of ordered pairs. Then the values of alpha and beta are, here we have to find the values of alpha and beta. Here f is defined like this, and given the function is in terms of ordered pairs. Understood, my dear children? Now see the options. First option 2 comma minus 1, second option minus 2 comma 1, third option 3 comma minus 1, and fourth option minus 2 comma minus 1. Okay, my dear children, out of these four options, first option is correct, that is 2 comma minus 1, means alpha value is 2 and beta value is minus 1. Let us see how the value of alpha is 2 and beta value is minus 1. See the explanation. Here the image of 1 is 1, the image of 2 is 3, the image of 3 is 5, the image of 4 is 7. Okay, my dear children, recall that previous knowledge. So f of 1 is equal to 1. This implies in this function we are substituting x is equal to 1. So alpha into 1, what will give it? Alpha plus beta, that is equal to 1. Similarly, f of 2 is equal to 3. F of 2 is equal to 3. Understood, my dear children? This implies f of 2 means alpha into 2. That means 2 alpha plus beta is equal to 3. Understood these two equations, my dear children? Now, if you observe these two equations, these are linear equations in two variables. You have already studied in the 9th class, 10th class, how to solve a pair of linear equations in two variables. Here also, these two equations are a pair of linear equations in two variables, namely alpha and beta. You have to solve them. By solving first and two equations, we get here alpha is equal to 2 and beta is equal to minus 1. Understood, my dear children? Right. Now come to the question number 5. If e power f of x is equal to 10 plus x by 10 minus x, comma x belongs to open interval minus 10 comma 10, and f of x is equal to k into f of 200x by 100 plus x square, then k is equal to, if a function is satisfying these conditions, we have to find the value of k. Understood the question, my dear children? Right. Now come to the options. First option is 0.5, second option is 0.6, third option is 0.7, and fourth option is 0.8. Now let us see the solution and as well as explanation. Okay, my dear children? Right. Now come to the solution. The first option is correct. Let us see how the first option is correct. What is given? Here e power f of x is equal to 10 plus x by 10 minus x. This implies f of x is equal to log of 10 plus x by 10 minus x. This is a exponential function. We can convert exponential function into logarithmic function like this. Understood this equation, my dear children? Right. Now it is given that f of 200x by 100 plus x square. Let us find the value of this one. Okay, my dear children, 210 plus x means 200x by 100 plus x square. We substitute in f of x. Okay, my dear children, understood this step, my dear children? Right. Now simply we simplify the numerator part as well as in the denominator part. Then we get here log of 1000 plus 10x square plus 200x whole divided by 1000 plus 10x square minus 200x. By taking 10 as common factor in the numerator and as well as in the denominator and striking out them, we get this step, that is equal to log of 100 plus x square plus 20x by 100 plus x square minus 20x. Understood this step, my dear children? Right. That is equal to log of In the numerator, if you observe this expression, it is in the form of a plus b whole square, and in the denominator, it is in the form of a minus b whole square, where a is equal to x and b is equal to 10. In the denominator also, a is equal to x and b is equal to 10. So we can write them as a plus b whole square in the numerator, in the denominator a minus b whole square. So a plus b by a minus b whole square by using the laws of exponents. Understood this equation, my dear children? Right. Again we use the properties of logarithmic functions. 2 into log of 10 plus x by 10 minus x. Understood this step, my dear children? That is equal to 2 into log of 10 plus x by 10 minus x is nothing but f of x. Okay, my dear children? So this value is equal to 2 into f of x. Now come to the condition. What is given condition? F of x is equal to k into f of 200x by 100 plus x square. It is a given condition. From this given condition, we have to find the value of k. Okay, my dear children? Right. This implies f of x is equal to k into 2 f of x. We have already found in RHS f of 200x by. Okay, my dear children, we got 2 f of x. We substituted that value in this step. From this equation, we get here 1 is equal to 2k. Understood this step, my dear children? This implies k is equal to 1 by 2. That is equal to 0.5. Is it clear, my dear children? Right. Now come to the question number 6. If f of x is a function such that f of x plus y is equal to f of x plus f of y and f of 1 is equal to 7, then sigma r is equal to 1 to n, f of r is equal to. Here the function is defined like this: f of x plus y is equal to f of x plus f of y. This is a given function f defined, and this value also given, f of 1 is equal to 7. Now we have to find the value of this expression. See the options. First option is 7n by 2, second option 7 into n plus 1 by 2, third option 7n into n plus 1, and fourth option is 7n into n plus 1 by 2. Understood these parts, my dear children? Four options. Out of these four options, fourth option is correct, that is 7n into n plus 1 by 2. Let us see how this fourth option is correct. See the explanation. First, let us see the given function f of x plus f of y is equal to f of x plus y. In this function, and also given that here f of 1 is equal to 7. Okay, my dear children, let us find f of 2. How can you find f of 2? F of 1 plus 1. 2 can be written as 1 plus 1. According to the function defined here, f of x plus f of y. Here x is equal to 1 and y is equal to 1. So f of 1 value is 7 plus f of 7 is 1 is equal to 7. 7 plus 7, 14. Understood this step, my dear children? Right. Now let us find f of 3 value. How can you write f of 3? F of 2 plus 1. Isn't it right? Right or not? Right. Now, according to the given definition, f of x plus y is equal to f of 2 plus f of 1. F of x plus f of y. What is f of 2 value? We got already here 14 plus f of 1 value is 7. Understood, my dear children? We got here f of 1, f of 2, f of 3. Okay, my dear children? Right. Sigma r is equal to 1 to n f of n. If we expand this sigma, what will you get here? F of 1 plus f of 2 plus f of 3 plus and so on plus f of n. You know f of 1 value is 7, f of 2 value is 14, f of 3 value is 21 and so on. If you observe this sequence, if you observe this series, it is in the form of AP. Okay, let us see common factor. So we are taking the common factor 7. So 7 into 1 plus 2 plus 3 and so on n. If you observe this one, this is the sum of first n natural numbers. Okay, my dear children. So 7 into sum of the first n natural numbers, formula n into n plus 1. So its value is 7 into n plus 1 whole divided by 2. Understood, my dear children? Right. Now come to the question number 7. If f of x is equal to Lx and a, b, c are in AP, k, l are constants, then f of a minus k, comma f of b minus k, comma f of c minus k are in dash. We have to find f of a minus k, f of b minus k, and f of c minus k. They are in AP or GP or HP or AGP. AP means arithmetic progression. GP means geometric progression. HB means harmonic progression. AGP means arithmetic geometric progression. Okay, my children, we have to find out in which progression these three terms are lies. Let us see the solution. The first option, that is AP. The three terms are in arithmetic progression. Let us see how these three terms are in arithmetic progression. Here it is given that A, B, C are in AP, already given in the question itself. A, B, C are in AP. Then if you subtract a constant, the same constant term from these three terms, then the sequence also in the AP. So A minus K, comma B minus K, comma C minus K are in AP. Here we substitute that K from all these three terms simultaneously. Then the resultant three numbers also in arithmetic progression. Understood, my children? Right. Similarly, if we multiply the same three terms by a constant term, then also the three terms will be in the arithmetic progression only. So here we multiplied these three terms by a constant L. So L into A minus K, comma L into B minus K, comma L into C minus K. These three terms are also in AP. Understood, my children? Right. This implies f of A minus K, comma f of B minus K, comma f of C minus K. The above three terms can be written like this: f of a minus k. Second term can be written as f of b minus k. Third term can be written as f of c minus k. So these three terms are in AP. Understood solution, my dear children? Right. Now come to the question number 8. If f is a mapping from n to z is defined by f of n is equal to 2 if n is equal to 3k, comma k belongs to z, that is equal to 10 minus n if n is equal to 3k plus 1 comma k belongs to z, that is equal to 0 if n is equal to 3k plus 2 comma k belongs to z. Here also the function f is a piecewise defined function because in the three different ways that function is defined. Okay, my children? Right. Then set of all n belongs to n such that f of n greater than 2. Okay, my children, we have to find that set. The first option is 3 comma 6 comma 4. Second option 1 comma 4 comma 7. Third option 4 comma 7, and fourth option is 7. Set 7. In these four options, second option is correct. That is set 1 comma 4 comma 7. Let us see the explanation. Set of all n belongs to n such that f of n greater than 2. We have to find this set. That is equal to set of all n belongs to n such that n is equal to 3k plus 1 comma k belongs to z, comma 10 minus n greater than 2. Okay, my children? Then we find these three values only. Set 1 comma 4 comma 7. Only these three natural numbers only satisfy the given condition. Understood, my children? Right. Now come to the question number 9. Set of all x belongs to R such that greatest integer function step of x minus modulus x is equal to 5. We have to find the set of all real numbers which satisfies this equation. Okay, my children? Now let us see the options. First option is real numbers. Second option is empty set. Third option is set of all x belongs to R such that x less than 0. And fourth option is set of all real numbers x belongs to R such that x is greater than or equal to 0. Out of these four options, second option is correct. That is empty set. So there is no real number which satisfies this condition. Let us see the explanation. Suppose if x is greater than or equal to 0, then mod x is equal to x. You know the definition of modulus of x. This implies x minus mod x is equal to 0. From this equation, we can write this equation. Okay, my children. This implies step of x minus mod x is equal to 0. We got here only 0. Not equal to 5. It is not equal to 5. Suppose if x is less than 0, if x is a negative number, then mod x is equal to minus x only. Okay, my children. then x minus mod x is equal to x minus of minus x, because mod x is equal to minus x. This implies we get 2x. This 2x value is also less than 0, because x less than 0, this implies 2x is also less than 0. Then its greatest integer function, step function, is not equal to 5, because it is a less than 0, negative number, not equal to 5. Understood the solution, my dear children? Right. Now come to the question number 10. F and H are from A into B, where A is equal to set A, B, C, D, and B is equal to set S, T, U, defined as f of A is equal to T, f of B is equal to S, f of C is equal to S, f of D is equal to U, h of A is equal to S, h of B is equal to T, h of C is equal to S, h of A is equal to U, h of D is equal to U. Which one of the following statement is true? The functional h and f are defined like that. Now come to the options. First option, f and h are functions. Second option, f is a function and h is not a function. And third option, f and h are not functions. And fourth option is f is not a function and h is a function. Okay, my dear children, out of these four options, second option is correct. That is, f is a function and h is not a function. Let us see how this is a correct answer. I have shown the given data in the arrow diagram. Function f is like this and h is like this. If you observe here, in the function f, every element in the domain is associated uniquely with the elements in the B. Means from every element in the set A, only one arrow is drawn. Not more than one arrow should be drawn. So it is a function. But in the case of H, if you observe here, from the element A in the domain, two arrows are drawn. These two are associated with the element A in the domain. So this is not said to be a function. This is only a function. Understood, my dear children? Right. Every element in A has unique F image in B. That implies F is a mapping from A to B is a function. Is it clear, my dear children? A has two H images, H and S and U. This implies H is a mapping from A to B is not a function. It is only said to be a relation. It is not a function. Understood, my dear children? Right.